Hey everybody, welcome back to some more live coding. Today we're going to talk about Rust, and in particular, Rust with WebAssembly. Let's see, so the agenda for tonight is here. I've jotted it down in this notepad. We're going to quickly talk about what is Rust and what is WebAssembly, just in case you're not familiar with either of them, and talk about why it would be a good idea to use it, and then kind of explain really quick how it works, and then we're going to do the tutorial that they provided. So, I've done 2 streams on Rust so far. The very first one was just called Learning Rust from Scratch, and I started learning how to use Rust in general. And I created some cookbook exercises there. We did a little packet capturing at the end. And then the next stream was just more cookbook stuff. And so that one included things like cross-compiling, how to cross-compile Rust to other... Let's see, so here I made a playlist. I called it Rust Stuff. Now there's only... Okay, it looks like I may have added this video twice by accident, but learning Rust from scratch, and then this building a Rust cookbook one, and in that one we did cross-compiling, threading, and how to link to a C library. And it turns out that linking to the C library is like the whole key to all of this. Now, the other day I heard someone just kind of mention in passing, you can compile Rust to WebAssembly. And a big light bulb went off in my head. I was like, what? Because I didn't really know much about WebAssembly at all. So when I looked into it, what I found was really interesting. So let me first pull open the cookbook we did. Yeah, so this cookbook on DevDungeon, github.com/devdungeon/cookbook. Yeah, right here. 19 days ago, updated Rust. So in the Rust folder of the cookbook, I've got all of the stuff that we did. So some quick notes on getting started. This is how you install Rust. This is how you compile. Rust is a programming language that compiles to a binary. It's supposed to be very fast and very safe compared to C++. And so we did a lot of different topics here: channels, command line arguments, cross-compiling, file I/O, HTTP request, and linking with C. Now this one is particularly relevant because essentially all you're doing with the Rust and the WebAssembly, and I guess real quick we can talk about what WebAssembly is. So WebAssembly 1.0 has officially shipped in 4 major browser engines. That is Firefox, Chrome, Safari, and Microsoft Edge. All of these support WebAssembly 1.0, so you can start using it right now. WebAssembly, abbreviated Wasm, is a binary instruction format for a stack-based virtual machine. Wasm is designed as a portable target for compilation of high-level languages like Rust and C++. What this enables you to do is to deploy on the web for client and server applications. And to give you a better idea of what that actually means, it basically means you can compile a binary and run it in the browser. That's essentially what it comes down to. Like, normally you would compile down to x86 64 architecture, right? And it'll run on your computer. But now you can essentially target a new assembly, a new machine language. It's called WebAssembly, and the browsers understand it. And it runs at pretty much native speed. So essentially all you're doing is you're creating a Rust library that you're linking with with JavaScript. I'm sorry. So the same way that we interacted between C and Rust is the exact same way pretty much that we're interacting between JavaScript and Rust. So in this linking one, let me pull open the code. So there's two parts to it. There's one which is calling the C library from Rust, and then calling the Rust library from C. And there's different ways to do these, but okay, so here's our source, and if we look at the main Rust file, you can see you call extern create libc, and then you just tell it you're using some libc stuff, and then you just define the extern. And this is where you basically say, hey, this function is not coming from Rust, it's coming from somewhere else. And so in this case, we're telling this is a C library, live multiply that we made in our case. But in JavaScript, you'd basically say extern alert, and you'd be calling a JavaScript function. And we'll go. Okay, so we'll go through the tutorial. Yeah, I'm probably not doing a very good job of explaining it here, but I was looking through their tutorial, and it turns out their example is John Conway's Game of Life. So I thought it was very fitting. So we're going to run through this. Yeah, it's supposed to be efficient and fast, safe as it actually runs in a sandboxed environment, so it doesn't have full access to your whole computer, which is good. Open and debuggable. You're supposed to be able to inspect elements and things. I don't know how that works yet, though. So let's go ahead and get started. What I'm going to do is open up my cookbook project. So we'll open folder cookbook. Now, in the Rust folder, I need to refresh here. So I've got Rust up and Rusty. I want to start a new project. Okay, so I do a cargo new. So we'll go into the Rust and we will do cargo new, WebAssembly example. Why don't we just do that? Okay, so who's this book for? Anyone interested in compiling Rust to WebAssembly for fast, reliable code on the web. You should know some Rust and be familiar with JavaScript, HTML, and CSS. You don't need to be an expert at any of them. Awesome. So it just says start with the tutorial. And that's what we're going to do. This is a tutorial that implements Conway's Game of Life in Rust and WebAssembly. Who is this tutorial for? Yeah, anybody who knows the basics of all of them. What will I learn? How to set up Rust toolchain for compiling WebAssembly, a workflow, how to debug, how to time profile, and how to size profile. Okay, cool. Sounds good. Setup. This section describes how to set up the toolchain. We're going to need Rust up, Rust C, and cargo, and I should have all of those. If you need Rust up, this is how you install it. But I'm just going to confirm I do have Rust up and Rust C. I do. The Rust and WebAssembly experience is riding the Rust release trains to stable. Okay. Wasm Pack. Wasm Pack is your one-stop shop for building, testing, and publishing Rust-generated WebAssembly. Get Wasm Pack here. Okay. I'm going to take notes on this. So I'm going to create a README inside my Wasm example. Okay, Rust and WebAssembly example. And I want to link to this book that we're doing. So let's put this in there. Tutorial followed for this example is that link there. And while I'm at it, why don't I throw up a link to the live stream? Copy link. And we'll say live stream of coding this project there, and we'll just call that some links. Okay, so where do we go from here? We need Wasm Pack. Okay, it tells us to just curl Rust Wasm GitHub Wasm Pack installer. Let's just go ahead and take a look at what that is, because it's never a good idea just to shell a script from the internet. So let's see what it actually does. Dude, it's just doing some Rust and some cross-compile stuff. Okay, it looks okay to me. We will go ahead and trust them and run this Wasm pack installer. Okay. Install Rust up, Rust C, and Cargo. Then install Wasm pack. And sure, I'm gonna link the toolchain stuff because I'm gonna want to know those later. Okay. Wasm pack cargo generate. Do I already have that? Cargo install, cargo generate. Okay. Cargo install, cargo generate. All right. Cargo generate helps you get up and running quickly with the new Rust project by leveraging a pre-existing Git repository as a template. Okay. npm, yeah, I should already have that. But npm install latest. Oops. Okay, sure. npm install npm at latest globally. I wonder if there's even an update. We'll just let that run and go on to the next page. Hello world, this section will show you how to build and run your first Rust WebAssembly program. A web page that alerts hello world. Mythic says it's Rust. Yes, it is. And Jeff Williams says, yes. Yeah. You know, several people have asked about the Rust stuff. And so I thought I'd do another one. Especially since I learned about this and I really wanted to share it. I thought it was really exciting and kind of blew my mind in how easy it was. And I didn't do it yet. I haven't done it. I just skimmed through the tutorial and all these light bulbs went off in my head. So you'll see it in a second as we get there. And let's see, make sure you have followed the setup instructions. Did I do that? Yeah, I already did all these. Okay, clone the project template. The project template comes pre-configured with sane default, so you can quickly build. Okay, so it wants us to run cargo generate. Wait, let's go into my project folder. Okay. Wait, so I already started a project. Well, let's go ahead anyway and do a totally new one. Cargo generate --git github.com/rustwasm wasm pack template. No such command. Is it still installing in the other one? It is. You can do it. Okay, so let's let the install finish first before we can run the cargo generate. But that's okay. This should prompt you for a new project's name. We will use Wasm Game of Life. So Eduardo asks, will you be able to do front end with Rust? And the answer is yes, because you can use it to do all the same stuff you can as JavaScript. Therefore, if you can do front end with JavaScript, you can do front end with Rust. And you'll see, I think it'll make sense. I think it'll all make sense in just a minute, in like one more page. Okay, enter the new Wasm Game of Life project and take a look at its contents. We'll see the cargo toml, which is going to have, let's see, this one comes pre-configured with the Wasm bind gen dependency, a few optional dependencies that we'll dig into later, and the crate type, properly initialized for generating Wasm libraries. Okay, let's see, almost done. It's at 199 of 201. Okay, then there's the lib.rust. The lib.rust file is the root of the Rust crate that we are compiling to WebAssembly. It uses Wasm bindgen to interface with JavaScript. It imports the window.alert JavaScript function and exports the greet Rust function. So Eduardo says, I don't understand exactly what WebAssembly wants to do. WebAssembly is basically the binary format that runs in browsers. Like, you can compile a .exe for Windows, you can compile an executable for Linux, you can compile one for Mac, and now you can compile one for the browser. It's essentially just another compile target for assembly, for binaries. And you can interact between JavaScript and Rust the same way you can interact between Rust and C, and Python and C, and things like that. So you can basically create native JavaScript extensions and libraries. The source live.js, yeah, that's the Rust crate we're going to do. Okay, so here is the code that really made sense to me, when made it all click. And it's this line right here. Right down here. I'm highlighting it, it says Wasm. There's a directive here, it says Wasm bindgen. So this is basically binding to an external. And look, it's just defining an extern for alert, which is the JavaScript alert. So the same way you just define an external function from C, from a C library, you're doing it exactly the same thing, except it's coming from JavaScript instead of a C library. So you just define the extern alert, and then you're calling the JavaScript functions in your code. And you can do it the other way around too. So let's see, is this done yet? Okay, this is done installing the cargo generate. So now I should be able to run this, and as far as a project name, we'll call it Wasm Game of Life. Okay, so now what I'm going to do is open up IntelliJ. Idea? Yeah, that's what it is. So IntelliJ, the JetBrains one, has a Rust module, or a plugin to do Rust programming, so I want to use that instead of VS Code. Okay. Here we are. Now, if we look in source, yeah, they showed us the live.rust file. And here it is. Here's where we're defining that alert. No cargo projects found. Okay, let's attach this to the correct cargo.toml file. And that should let it finish indexing everything properly. No. Okay, yeah, so here it's got red squigglies and it says call to unsafe function requires unsafe function or block. Now that's like a linter being helpful. So let's see, what if we add unsafe to function? I wonder if that'll break anything. I'm gonna go ahead and add that, even though I don't know if that will break it. And then the utils module provides common utilities for making Rust work with WebAssembly easier. So let's check that out. Oh, there's only one function. Basically, it just says if there's an error, do some error stuff. Yeah, let's just let it be. Okay, so there's some boilerplate at the top: extern, crate, wasm, bindgen, mod, module utils, using bindgen stuff. And then yeah, it's just saying, so I bet the same way you could probably just like you could do, if we just duplicate it, I'll comment it out because I don't really want to do it, but theoretically I'm guessing you could just do the same thing, like get element by ID, and you could just as easily call that JavaScript function. So you could just as easily get and modify the DOM, I'm assuming. I mean, we'll find out, I guess. And then run. Okay, so this looks good. Let's go back to the tutorial here. So now we just build it. We use WasmPack to orchestrate the following build steps. ensure that we have Rust 1.30 or newer, and the Wasm 32 unknown targets via Rust up. Okay, so I don't think I have that. I think I can try Rust up targets. No. Rust up target list. Okay, it's got a whole bunch already. And so this is how you do the cross-compiling too. You just set different targets. But we wanted the Wasm. There it is. Wasm 32 unknown unknown. Okay, so we do have it. Wasm 32 unknown unknown. Compile our Rust sources into WebAssembly.wasm files, binary, via cargo. Use Wasm bindgen to generate the JavaScript API for using our Rust-generated WebAssembly. Wow, so it's really taking care of all the heavy lifting. To do all of that, run this command, wasm pack build. Alright, wasm pack build. Downloading components for Rust STD. Installing components for Rust STD. Alright. Compiling proc macro, Unicode, Wasm bindgen, sin, config if, lazy static, bumpalo, Wasm bindgen, log, quote. Alright, let's let that build and go back to the tutorial. Okay, so when the build is completed, we can find its artifacts in the package directory. Okay, so it's got a package.json just like a normal Node.js package. And then it's got a Wasm and a couple TypeScript files. Well, that's the TypeScript declarations, so that's got the types. And then there's the JavaScript. The README file's copied from the main project, otherwise the rest are new. Okay, so you get the Wasm file itself, which is the binary. It's going to be smaller than any code written in JavaScript, and it's going to be faster. The Wasm file is the WebAssembly binary that is generated by the Rust compiler from our Rust sources. It contains the compiled to Wasm versions of all of our Rust functions and data. For example, it has exported our greet function. It actually, yeah, so that unsafe did break it. So that little linter tip was not good, so I'm going to bring it back to where it was. Alright, now it's all done. Done in 1.34 seconds. Okay, smiley face. Your Wasm package is ready to publish at package. And here it is. Okay, and then we've got our types. Yeah, our declarations file, which has our types, and that's our function we created. This is the JavaScript that binds it all together. And let's see how this works. So, get string from Wasm. There's our function, where it exports function. It's got some heap. Yeah. Luckily, we don't have to worry about any of that. We can just trust the tooling. And then, okay, more declarations, and then the actual binary file. So there's the, and then the package.json. So here we can see, you know, we can publish this right now to npm, I guess, because it is a package.json. You could publish, yeah, files, the Wasm, and the JavaScript and the type declaration, which is like the header file. So this is like the compiled C library, and this is like the header file, the dot declarations for TypeScript. So that's essentially how you compile a library for the web. So now let's try it out. Okay, and then it says, yeah, the .js file is generated by Wasm bindgen and contains JavaScript glue for importing DOM and JavaScript functions into Rust and exposing a nice API to the WebAssembly functions to JavaScript. For example, there is a JavaScript greet function that wraps the greet function that we created in Rust that was compiled to WebAssembly. Right now, the glue isn't doing much, but when we start passing more interesting values back and forth between Wasm and JavaScript, it will help shepherd those values across the boundary. Okay, so it does a lot of the work for us. Yeah, we just basically say export. Oh, I guess this is... Oh, that's part of the JavaScript file that was generated. And then the .d.ts is the TypeScript declarations for the JavaScript glue. Yeah. And then package.json. This is used by NPM and JavaScript bundlers to determine dependencies across packages, versions, blah blah blah. That's a totally normal package.json. There's nothing special about it except that it includes the Wasm file. So that's it. And then putting it into a web page. So how do we finish this all up? Take our Wasm Game of Life package. We use the create Wasm app JavaScript project template. Hold on. Run this command within the Wasm Game of Life directory. npm init Wasm app www. Okay. So we're going to create a kind of a project inside this project that has the HTML files to actually present it. Okay, so we're going to do init Wasm app www. Alright. So we should have a folder called www now. There we go. And it's got the index.html. And it's got one script in it with bootstrap.js. And what does that do? A dependency graph, import index.js. Okay, index.js. Now that imports our hello Wasm pack, which, oh, it automatically knew our function name? Interesting. Very interesting. Let me try something. I want to now... I want to delete that www we just generated. I want to go back here, and I want to change this from greet to hello. I just want to see... And the package, I guess, was the built code that we can delete too. Now, is that the only place? Is that the only place I need to update that? There was also... Okay. Because when I did the www generate, it like knew the function name, and that kind of tripped me out. So let's see. Yeah, we got to do Wasm pack build. And then that should give us our package directory with package.json. And that all looks good. And then our type. Okay, yeah, so now it exported our hello. So then instead of Wasm pack build, we can do the init Wasm app www again. And then let's check out our www folder. Why don't we open that, show in files, and then, well, let's do this. Let's www, and then I'll do python3-m http.server and pop it open. Okay, so we are looking at the file. It says hello Wasm pack. Okay, but nothing happens. I was expecting it to code 404 message file not found. Maybe that's a little different. So let's check this out again. Bootstrap.js, index.html, index. Yeah, so okay, greet. Now, did I need to update something else so that it knows what to do? I don't think so. I think that's just like the default. I don't think this actually is smart enough to know. But that should be okay. Now let's try it. Maybe that's why it wasn't working. So now if we go back to here, we should get our alert. We should get our alert, please. Hello, alert? No, we didn't. Okay. Then I'm gonna try something. I'm gonna delete these again. And I am gonna go back here. And change this back to greet. Just to make sure. Okay, so we gotta do Wasm pack build. And then we're gonna do the npm Wasm init again. Now, why is it taking so long to build this time? Okay, so... Oh, did I close the whole tutorial? Come back. Okay, so it was Rust and WebAssembly tutorial. Here we go. Where were we? Yeah, so we were just finishing up this hello world, basically. Putting it into a web page. Run this command, npm init. Yeah, so I think this is probably done. So now we can run the npm init again. And then we'll start up the web server. I guess I should. There we go. Okay, now I'm not seeing the alert. I thought I should be seeing the alert. Import index.js. Wasm.greet. Oh. Let's see, does it need... Interesting. It doesn't seem to be working. Once again, let's take a closer look at some of the files. Package.json. Do I need to install the package? Do I need to, like, npm install this package? Oh, there's a start. There's a... Okay, why don't we try this? npm runs... So, oh, that is the dub. Yeah, why don't we just try npm run start? Oh, it failed. Interesting. Webpack dev server not found. Oh. Maybe I need to install Webpack. 1 second, I'm gonna grab some water. Oh, Jeff is saying yes. I think Jeff might be saying yes, I need to install it. Oh no, you're just saying yes, there is a start command. Okay, we're getting closer. We're getting closer to getting the run script. The CLI has moved into a different Webpack CLI? Okay. I'm not very familiar with Webpack. I understand at a very high level what it does, and I know that like when you do a React Native app, it uses, like it'll hook up Webpack to do all the good stuff for you, but that's one thing I haven't dove deep into. Okay, so now can I do the run start? No, there's still one more. Maybe, let's see, so hold on a second. Is this one gonna tell me the dev dependencies? Yeah, okay. npm install. So, let's see. I should be able to install the dependencies. So let me just try. This should, by doing the npm install this, that should install everything, including the dependencies, so hopefully that will sort things out instead of me installing those packages globally. Okay, so now we've got a huge list of messages. Oh, we got the alert now. Great, so I want to... Oh no, I didn't want to close that. Okay, well what I want to see now actually is if I do... Now that I have the npm module installed, will that make a difference if I just load up if I just load it up via regular... Oh. No, that doesn't work. That's interesting. So, how would I actually deploy that if it's not just load up and serve the HTML file? Okay, let me go back and read this tutorial now. So, the package.json comes pre-configured with Webpack and Webpack dev server dependencies, as well as the dependency on hello Wasm pack, which is a version of the Wasm pack template package that has been published to npm. Then there's the config.js. This file configures Webpack and its local development server, comes pre-configures, and you shouldn't have to tweak this at all to get Webpack and its local development server working. Okay, and once I realized, yeah, that I needed to just install it, it was all good. So now I should just be able to do npm run start. I think there's actually a shortcut. I think you can actually just, yeah, npm start is all you have to run. Okay, so yeah, that's working now. Now that that's working, I want to go back and verify, like if I go back here and I just change this to hello, I want to change that. Like how much changing do I have to do? Okay, so this has not recompiled my code yet, so I think so the index.js, yeah, I'm gonna call this, but then that's not gonna work because the Wasm file, wherever it is, where is that Wasm file? Oh, I guess it knows like that it's pulling from, because this is the development server. Yeah, so this should give us the old message still. No, it doesn't give us anything. Okay. Export hello was not found. Okay, yeah, so let's do the, we have to, where is it? Wasm pack build? Oh yeah, I'm in the wrong directory. So we have to run the build to update our Wasm file here. Now, if we refresh the browser after we run npm start, uh-oh. Oh, I gotta go back into the www now. npm start. Okay. No, it's still complaining that it can't find hello. Okay, so these updated. Now it looks like that something in the www folder did not update, which means, so where is that getting? Not here. Interesting. So, oh, do I maybe need to? Do I need to run the npm install again? I need the Wasm build. I thought I did. I thought I did the Wasm build. Jeff, let me see. So I did Wasm pack build. Now, was there another one I forgot to do? Let me see. Let me try again. npm start. npm start. Export hello was not found in hello Wasm pack. Oh, I guess because that hello Wasm pack was their dependency, their create app. That's why. Here it is, hello Wasm pack, and that's the one I think that just wants you to do one thing. Wasm pack. Yeah, run. Oh. No, Wasm pack should automatically run that bindgen documentation. Okay, so index.js, there's hello. I'm trying to figure out where the reference got broken. And I think it's kind of buried somewhere that I can't see. Well, I guess they're gonna, in the tutorial, hopefully they'll explain how to add more functions. Okay, so let me try again. We're gonna try, now that we broke it again, let's see if we can fix it. And then dub start. Okay. Oh no. Now, okay, npm install dot. See, now it's saying hello is not there. Oh, because I think I need in here I need to fix that one. From hello Wasm pack. There, that's where it is. That's where it is. And that is coming from, it's coming from the npm module itself. That's why. So their example, their hello Wasm pack example, really is kind of hard-coded with that function. And we would basically just replace that with our own, so that really clarifies what I was looking to understand. So that's all good. But now that we fixed that, this should be good again. There's our alert. Okay. So I was just playing with that to make sure I really understood what was going on. So then the index.html, this is the root index. It doesn't do much other than load bootstrap.js, which is a very thin wrapper around index.js. And index.js is the one that just imports our stuff. Okay. The index.js is the main entry point. It imports hello Wasm pack npm package. Install the dependencies. First, ensure your local development server and its dependencies are installed by running npm install. Okay. Probably should have just kept reading the tutorial. This command only needs to be run once and will install the Webpack JavaScript bundler and its development server. Yeah, so... And again, just to confirm, if I try and load this up in a regular browser, it does not work. Okay. Rather than use the hello Wasm package from npm, we want to use our own Wasm Game of Life package, yes. This will allow us to incrementally develop our Game of Life. First run npm link inside the package directory so that the local package can be depended on by other packages without publishing them to npm. I didn't know you could do that. npm link, huh? Okay, so I guess it created a symlink. Yeah, it looks like it just created a symlink to this folder. Okay. That's straightforward enough. We should do the link, yeah. Second, use the npm linked version by running this command within the www. Okay. Okay, so that set this local npm node or this local node modules to my symlink of there. Okay, got it. Finally, modify index to JS. Yeah, so that we're importing our module instead of their module. And we want to install Wasm Game of Life. And yeah, if we control mouse over, we can go into it and we can confirm that this is where it's linking to directly. That's where it's pulling from. And this is where I could change it to hello. I would need to go to my source, change this, then I'd need to run the build, Wasm pack build, and then back into www npm start. I think that'll do it. I think that will do it. It's 8080. There it is. Awesome. I should have just kept reading the tutorial, but I guess it's good to like explore a little bit and then get confirmation or not. Okay, our web page is now ready to be served locally. Serving locally and run npm start. Okay, yeah, already did that. Exercises. Modify the greet function to take parameter, change, rebuild. Yeah, okay, cool. We already did pretty much that exercise. If you are already familiar with Conway's Game of Life and its rules, feel free to skip to the next section. Now, I did a stream on Conway's Game of Life already. If you're not familiar with it, it's super awesome. You gotta check it out. And read up Eric S. Raymond on the glider symbol. Read up, yeah, the glider, a universal hacker emblem. Give this a read up on catb.org. But Game of Life is awesome. I did a Python implementation the other day on a stream, and I have a Ruby one, and I have a Go one, and now I'm about to have a Rust WebAssembly one. Okay, so yeah, we actually know. I'm going to skip over all this because I'm going to assume you guys also know what Game of Life is already. So, implementing Conway's Game of Life design. Before we dive in, we should have some design choices to consider. Infinite universe. The Game of Life is played in an infinite universe, but we do not have infinite memory. Working around this is rather annoying and comes in 3 flavors. Keep track of a subset. Create a fixed size universe where the cells have edges. Third option is what we're going to do. Create a fixed size periodic universe where cells on the edge have neighbors that wrap around to the other side. Because neighbors wrap around the edge of the universe, gliders can keep running forever. That's fine. Interfacing Rust and JavaScript. This is one of the most important concepts to take away from this tutorial. JavaScript's garbage collected heap, where objects, arrays, and DOM nodes are allocated, is distinct from WebAssembly's linear memory space, where our Rust values live. WebAssembly has no direct access to garbage collected heap. JavaScript, on the other hand, can read and write to the WebAssembly linear space, but only as an array buffer of scalar values, like an unsigned int, a regular int, or a float. WebAssembly functions also take and return scalar values. These are the building blocks from which all WebAssembly and JavaScript communication is constituted. Wasm BindGen defines a common understanding of how to work with compound structures across this boundary. Yeah, we already kind of saw that. And that's where it does all the work for us, basically. It involves boxing Rust structures and wrapping the pointer in a JavaScript class for usability. or indexing it into a table of JavaScript objects from Rust. Wasm bindgen is very convenient, but it does not remove the need to consider our data representation and what values and structures are passed across this boundary. Instead, think of it as a tool for implementing the interface design you choose. When designing an interface between WebAssembly and JavaScript, we want to optimize for the following properties. Minimizing copying into and out of the WebAssembly linear memory. Unnecessary copies impose unnecessary overhead. Yep, they take up more space, more time. Minimizing serializing and deserializing. Similar to copying, serializing imposes overhead we don't want. If we can pass opaque handles to data structures, instead of serializing and sending them back and forth, it'll reduce a lot of overhead. Bindgen helps us define and work with opaque handles to JavaScript objects. Interesting. So we can kind of reference them directly in memory if we have the proper mapping. As a general rule of thumb, a good JavaScript to WebAssembly interface design is often one where large, long-lived data structures are implemented as Rust types that live in the WebAssembly linear memory and are exposed to JavaScript as opaque handles. JavaScript calls the exported WebAssembly functions to take these opaque handles, transform their data, perform all the heavy computations, query the data, and ultimately return a small copyable result. By only returning the small results of computation, we avoid copying and or serializing everything back and forth between JavaScript, garbage collected heap, and WebAssembly linear memory. Yeah, so if you can keep it off of the garbage collected heap, then it never has to get dealt with the garbage collection either. Okay, interfacing Rust and JavaScript in our game of life. Let's start by enumerating some hazards to avoid. We don't want to copy the whole universe in and out. We do not want to allocate objects for every cell, nor do we want to impose a cross-boundary call to read and write each cell. So we're going to have to create direct memory access for JavaScript. Where does this leave us? We can represent the universe as a flat array that lives in the WebAssembly linear memory and has a byte for each cell. 0 is a dead cell, 1 is a live cell. Here's what the 4x4 universe looks in memory. Okay, yeah, it's just 4. A byte for each one. To find the array index of a cell, we can use this formula. Yeah, okay. That's pretty straightforward. It's just one long array. We have several ways of exposing the universe's cell to JavaScript. To begin, we will implement standard format display for universe, which we can use to generate a Rust string of cells rendered as text characters. This Rust string is then copied from the WebAssembly linear memory into the JavaScript string and in the JavaScript garbage collected heap. It is then displayed by HTML text content. Later, we'll evolve this implementation to avoid copying the universe's cell and to render to canvas. Another viable design alternative would be for Rust to return a list of every cell that changed states after each tick, instead of exposing the whole universe. This way, JavaScript wouldn't need to iterate over the whole universe, only the ones that changed. The trade-off is that the delta-based design is slightly more difficult to implement. Yeah, we don't need that much efficiency in our game of life example. We'll just crush your CPU. Rust implementation. In the last chapter, we cloned an initial project template. We'll modify that project template now. Let's begin by removing the alert and greet. Okay. And replacing them with the type definition for cells. Okay. So where were we? We have our live function, or our live file. Yeah, we want to get rid of our alert and our hello function and basically start over. And so we're going to create a public enumeration called the cell, and we're basically just going to create aliases for dead and alive so that they're easier to refer to, though it still just represents a 0 to 1 under the hood. We need to give it some decorators or whatever they're called in Rust. So Wasm bindgen is going to tell it that we need to expose this to JavaScript. reprint U8, I guess that's just saying represent it as an unsigned integer, an unsigned 8-bit character byte. Derive. Now this, I'm not sure about this one. I guess this is saying give it these abilities. It is important that we have the repr U8 so that each cell is represented as a single byte. Yeah. Okay. It is also important that the dead variant is 0 and alive is 1, so we can easily count a cell's neighbors to see if they're alive or dead. Optional values. Is that what the derive is? Optional values. Let's see. Next, let's define the universe. The universe has a width and height. Okay, so yeah, let's go ahead and make our public struct called universe with the width that is of type 4 bytes, unsigned 32. Height, unsigned 32. Cells is going to be a vector of cells. Okay. To access the cell at a given row and column, we translate the row and column into an index. Oh. Okay, so... interesting. Impl universe, function get index, and it needs a couple parameters, so it needs a reference to itself. The row, we need to know what row they want access to, and the column, which is going to be the same thing. And it's going to return a size, a U size. And then we're basically just going to say, get the straight linear point off of it. Basically, since it's a flat, we just jump up as far as we need to go to get the correct row as a U size. And I guess you don't need a return statement. I guess it automatically assumes the last statement in the function is the return. Okay. In order to calculate the next state of the cell, we need to get a count of how many neighbors are alive. Yep, that's another... Now... Okay. Function, so we can get the live neighbor counts. That also needs a reference to itself. And we also need to know which neighbor you're interested in, so we need the index, or the cell position, right? The row and the column. And then what it's returning is in unsigned 8. Unsigned 8 bits. And we're going to have a mutable count starting with 0, and then we're going to count up the neighbors. And because that logic is... It's not super difficult. You basically count the cell to the top left, top middle, top right, to the left, to the right, to the bottom left, middle, and bottom middle, and bottom right. You count all those and you add them up. And what's going on here? Why does it throw in all these errors? All I did was copy and paste. Oh, I know why. Because I actually need to return counts. There we go. Alright. So that's all this does is counting up the neighbors to all of the edges around it. And we did that in the other day example, so if you want to understand how that works more, you can maybe check out that other stream. The live neighbor count method uses deltas and modulos to avoid special casing on the edges. Okay, that's nice. I'm not too interested in the logic of how they did that. I want to see how this... Oh, wait a second. Is this more? We will put... Now we have everything we need to compute the next generation. There's a tick function now. Now hold on a second. Now each of the game of rules follows a straightforward translation into a condition on a match expression. Additionally, because we want JavaScript to control when tick happens, we will put this method inside a Wasm bindgen block so that it gets exposed. So you don't create multiple, can you? Do you create multiple impl universes, or do you have to put them all inside like this one? I guess, I mean, it's not complaining. So I guess I can just Wasm bindgen this one. So far, the state of the universe is represented as a vector of cells. To make this human readable, let's implement a basic text renderer. By intimate, let's see, so... Okay, it's going to basically create a print function. Thanks, Jeff. Jeff says you can have multiple impulse implementations. Okay. Okay. Now I'm confused about where to put this. Like, can I put that just like anywhere? I guess it's not much different than just saying, okay. And I'm just going to copy that over. So it's created the display that's going to take the cell and basically output these Unicode characters for an empty cell or a dead alive cell. Finally, we define a constructor that initializes the universe with an interesting pattern of live and dead cells. Okay, so within our Wasm bindgended one, we've got the new and the render. So in the one that's exposed, past the tick, we're going to add some more, which is the new. I guess that creates a new board, and render, which calls the toString, which was defined, I think, up here. I think that's what that one does. With that, our Rust, half of our game of life is implementation complete. So now it says we can give it a recompile and a try. So Wasm pack build. I'm gonna have to go back a directory to do that. Oh, there was an error. The trait, did you mean column exclamation? Interesting, okay, hold on. Expected value found macro column. Universe Wasm bindgen convert into Wasm ABI. Now hold on a second. Which line exactly is it complaining about? 95? No. 83? 83 and then 95? 83... Now... Interesting. Should that not be call? I think that's what that's supposed to be, actually. I think that's supposed to be call and match the input parameter. Okay, it looks like they just had like a typo in the example. Okay, now there's still this other one that it didn't like. The trait Wasm bindgen is not implementable for universe? Okay, hold on. Let me do a quick Googaloo. Let's see. Yes. Could it be translated? Oh, something to do with this, maybe the strings and the conversions. Let's see, maybe. Does this one need to go inside of that exported one? No. No, that didn't look like it mattered. No. Required because of the requirements on the impl of Wasm bindgen convert. Now where's that? Line 83? Oh. What's going on? So what's going on here? The trait-bound universe Wasm bindgen convert into Wasm ABI is not satisfied. Let me go back to the code here and see. Let's see if I missed something. By implementing the display trait from Rust standard library, we can add a way to format a structure in a user-facing manner. This will automatically give us a .toString method. Finally, we define a constructor that initializes the universe with an interesting pattern. Okay, so we've got that constructor. Now wait, maybe the... No, see, those are going within public methods exported to JavaScript. New, render, and the one that we created before, tick. Interesting. Let's see, maybe if I put that one at the end, it'll do something? No, no difference there. Okay, line 81. I'm not sure what the problem is here. I'm not familiar enough with Rust to understand what it's actually complaining about here. No, let's see. What am I missing? I'm not seeing anything obvious that I'm missing. It's saying a trait isn't fully implemented. Oh. A trait isn't fully implemented, and the only trait that we did implement was this, right? And I copied that straight from the example. Required because the requirements on the impl of Wasm bindgen for universe. Yeah, I mean, one of these isn't happy. Maybe... I don't know. I mean... maybe that needs to go inside the exported one as well. Maybe that also needs to go inside here. No, I already tried that earlier. Oh, unused import now? Now it considers... Oh, wait. Unexpected token. Yeah, it barfed all kinds of things out when I tried to put that inside there. It kind of worked better without it. I've only got this one error. Into Wasm ABI. Now that is... Oh! Is it complaining about the way it's represented or something? Like, do I need more of those... Do I need more of those directives like this? Like it's missing some of those? Let's see. Wasm bindgen is a trait. Yeah. Oh, well, I think they said this is a trait too. But yeah, this is the one that they're saying is not, they're not happy about. But why not? I mean, Wasm bindgen doesn't know how to handle the universe. Right, but that's what the whole this Wasm pack is supposed to take care of all that, right? So no, I don't want the package, I want my source code. So do we need to expose this struct? Like, is this what we need to expose? Ha! Alright! I guess that's what it was. I was looking down at the impl part thinking it was having trouble, but I guess I never exported the universe object itself. And if you don't export the universe object itself, then you can't export the sub-functions on it. So I'm curious, did I miss that? I did. I totally missed that part right there. Okay, so now that that's going, we can actually check. So let's go to www and do npm start. Got it. Okay, well, it says it ran okay. Maybe it's in the console? Is that... Oh no, error. Hello, hello's not a function. You're right. No, it's not. So it's up to me to actually update the index.js. Yeah, let's go back here. And yeah, so now we built by running wasm build. Done. Good, good. Now we can move on to the rendering part. First, let's go to our index.html and add a pre-tag with... yeah, we'll leave the bootstrap.js. Create some room. Oh, I guess it wants us to put it first. Okay, so now we've got our pre-formatted area with an ID of Game of Life canvas, okay. Additionally, we want the pre-centered. We can use CSS flex boxes to accomplish this. Add the following style tag inside the header. Okay, so inside the head here, we're going to add some style that just styles the whole body and gives it a width and a height so that we can align things in the center. At the top, let's fix our import to bring in the universe rather than the old greet function. Okay. Yeah, so now it does see our universe. Let's get that pre-element and instantiate a new universe. Okay, so this is still inside of our index.js. We got our universe imported. Now we basically want to say our HTML element, the pre that we created, is get element by ID, and the ID was game of life canvas. Okay, so now we've got our element, and now we're going to create a new universe. The JavaScript runs in a request animation frame loop on each iteration. It draws the current universe to the pre and then calls universe tick because we exposed this and that. Okay, so we're going to create a render loop function, and then we're going to set. Okay, so universe.render, if we go back here, our render function is the one that returns the toString, which we define down here. So when we call toString with the render, it's basically going through all the cells and creating a big string that has all of the cells. So then we're basically setting the HTML element content to that. But now we actually need to call render loop somewhere. Oh, actually, so we're going to render it, and then we're going to call universe.tick to generate the next generation. And then request animation frame render loop. Okay, and then to start the rendering process, all we have to do is make the initial call for the first iteration of the rendering loop. So okay, so we call 1 with this, and then it constantly ends up just repeating and calling itself. I'm not sure how the timing works on that. Let's see, in the tick, did we set the time up? No, there's no time. There's no time being specified yet. Okay, so now let's go back. Oh, I had a typo in here in the canvas. Oh, there it is! Look at it go! That's so awesome. That looks pretty good, too. For just being the text, the actual text characters. And it's running very smoothly. Yeah, that's cool. Okay, it's always fun to watch. Okay, so now how do we... I bet it's going to tell us about the speed next. Okay, so now, like right now, we're copying out the whole string, which is not very efficient. Yeah, so doing that makes unnecessary copies of the entire cell array. As the JavaScript code already knows the width and height of the universe, and can read WebAssembly's linear memory, we'll modify the render method to return a pointer to the start of the cell's array directly. Also, instead of rendering Unicode text, we'll switch to using the Canvas API. We will use this design for the rest of the tutorial. So inside our index.html, let's replace the pre with the canvas. Okay. Now it's a canvas. To get the necessary information from the Rust implementation, we'll need to add some more getter functions for the universe's width, height, and a pointer to its cell array. All of these functions are exposed, so we are going to put them inside the exposed one, the one that's exposed with the bindgen. So I'll go ahead and add these down at the bottom of that implementation. Okay, so we're gonna add a public function called width that needs a reference to itself. So kind of like Python, it always needs a reference to itself as the first argument. And all we're doing is returning information. So let's go ahead and just duplicate that for the height and just return that too. And then we're gonna have a public function called cells with a reference to itself. And what it's going to return is actually a pointer. We're exposing a function that's straight up returning a pointer to JavaScript. So how's JavaScript going to handle that pointer? I guess because it knows, it's going to know that it's an array, and we told it how to represent it. We told it to represent as 8 bits. So when I guess that's how it knows how to increment the memory. Next, in Wasm Game of Life Index.js, let's also import cell and define some constants that we'll use for the canvas. Okay, so yeah, let's also import cell, and let's add some constants up here. So the cell size in pixels is going to be 5. Grid color is, let's see, grid color, we'll do what they did. Dead color, we'll do black. And then the alive color will be cyan. How about that? Now let's rewrite the rest of the JavaScript code to no longer write to the pre's content data, but instead to draw to the canvas. Okay, yeah, so instead of getting the pre, we actually want to get the canvas. It's not constant canvas. And then here, instead of doing that, we want to... Okay, so yeah, I'll just copy this. So we just, to define the height and width, we're going to take the cell size times the height. I guess we can put that... Oh, yeah, we need that after we actually define the canvas. And so we're basically setting the canvas to fit perfectly for the size of our cells in our grid. Okay, and then we got to get the context from our canvas. And we're just getting a 2D context. Okay, so then... Okay, so we're replacing that universe render that we had with draw grid and draw cells. Get rid of that. And then we're actually going to define those here. And so that's going to be a function, and so is draw cells, or draw cells. Okay, and so drawing the grid's good. We're going to take the context, and we're going to start drawing. We're going to make stroke style equals grid color. And then for I equals 0, all the way to the edge of the canvas. We're going to move 2. We're going to basically draw 1 square at a time. Plus 1, 0. So that's going to move to the correct row. And then it's going to draw a line. Cell size plus 1. Okay. And then the horizontal lines, I'm just going to copy this over. Okay, and then, so we tell it to draw, and then we basically tell it to do the stroke. So that should draw the grid, and then we also need to draw the cells. We can directly access WebAssembly's linear memory via memory. Oh, well that's pretty straightforward. Which is defined in the raw Wasm module, Wasm Game of Life BG. To draw the cells, we get a pointer to the universe's cells, construct a uint8 array overlaying the cell's buffer, iterate over each cell, and check the value. Okay, so up at the top, let me see how that looks. From Wasm Game of Life BG. I guess that one gets built automatically. Because that's not one. Oh, that's BG stands for BindGen. Got it. So that's the BindGen stuff doing all the heavy lifting. And so from there, we can grab the reference directly to our memory, which is very cool. That is actually really cool. So we're going to need some more functions here. Get index and draw cells. Okay, well, get index. Shouldn't that one reference the memory? And then draw cells. Okay, let's see here. So I'll put draw cells right next to draw grid. Oh wait, I already did. Here it is. So that's, you got a cell pointer called universe.cells. Oh, and that's because we exposed that in our universe. Cells. Oh no. Did we not? Where is it? In our library, we should, yeah, cells is a public function that's being exposed. I guess I must not have built. Let me do, yeah, wasm pack build. Okay, now, there we go. Now we can see the cells function is exported. And it does, in fact, return, where is it? Cells? Yeah, it returns a pointer to itself, to the cells. Okay, awesome. So now we've got the pointer, and the cells is going to be a new uint8 array, which is going to map directly over the memory buffer at the offset of cells pointer. Is that right? Yep. Looks like there's one more argument. Oh, another offset from the base pointer. So we're basically saying, hey, hey WebAssembly, give me your raw memory buffer, and then within your buffer, start at this location, because I know there's a data struct there, and then from there, I want you to even go an offset of this index. And the index is based on the fact that it's mapping an array of 8-bit ints over it. Okay, that's really slick, honestly. Okay, let's go back here. And then context begin path, we're going to start a new drawing path, since our goal here is to draw the cells. And then I'm actually just gonna copy over this chunk here. So that's basically iterating over every row, and for each one setting the fill style on the context, and then saying context do a rectangle at these coordinates of this size. And then we need to say, okay, go ahead and actually draw it. Blit it, I guess, essentially is what it's doing. And then, yeah, our rendering process here is going to look the same, pretty much. Now we call draw grid, draw cells here before we call request animation frame. The reason we do this is so that the initial state of the universe is drawn before we make modifications. Instead, if we simply called request animation frame, we'd end up with a situation where the first frame that was drawn would actually be after the first call, which is the second tick. Wait a second. Oh, I see what it's saying. It's saying down here, we actually need to do those at least once to start it off. Got it. Otherwise, if we didn't, we'd end up with a situation where the first frame that was drawn would actually be after. Yeah, so it basically just gets out of sync. It works! Oh, does it? Well, let's try. Okay. So now let's do our Wasm pack build. And then we will go and do npm start and bask in the glory. It works! Wait. They said it should work. Alright, let's see what's going on. Console error? Height is not defined? Oh, okay. Index.js. Height is not defined. Height. Oh. Canvas height. No, good point. Where is... Are we exposing that from here? Universe with height? I guess we should do universe.height. But we don't have a universe yet? Okay. Let's make the universe there. That should be universe.height and universe.width. Width is not defined still. Where else am I using it? Oh. Now, did I? Because they didn't call all of those universe.width, so I must have missed. Did I miss a spot where I'm supposed to call, like, hey, width equals universe.width, or is that just kind of a... Or was I supposed to put... let's just... I mean... Let me just try this. There should also be one for height. Height should also be universe.height. Let's just go ahead and find all of them. Let's see. uint array 8 is not defined. Interesting. Unresolved. Did I, uint8 array. Oh, I guess I had a capital I there when I shouldn't have. It should have been lowercase I. And now still one more. Argument 1 of window request animation frame is not an object. Let's see. Do I need to call... Do I call that parenthesis? Oops. Okay, now let's go back to the very end where I call render loop. Yeah, I should not have the parentheses there. Oh, we're almost... we almost have it. Okay, let me try to build, just in case there was any changes. Did I import universe? Yes, I did. Universe is imported up here. Okay. Now... source map errors are JSON files. No. I don't know what that means. Source map error, type error, sock.js, JS map in clients? Oh, that's the npm thing. Okay, so we got close. We got close. Now why isn't it working? Oh yeah, here it is. They do bind width and height to universe width and universe height. Oh, and they're functions. That's why. That's probably why they bound it to a variable. Because... let me undo all of those. Because otherwise you're calling the function every time to do it. So let's just call the function once and set them. And then I also need to fix that, and I also need to fix that. And now we should be better. We should be better, and oh, we're so much better, we're working. Now how do you set the speed? This is bothering me. Request animation frame, set speed. Let's see. No, I thought there'd be like a nice easy way to set the frame rate on your animation. There's really not just like a set frame rate option. I guess, you could set your own sleep timer. You can set your own delay, I guess. But that's okay. Oh, whoa, look at how it starts out. That's kind of cool. Well, I mean, it's working. It's working, and I learned a lot. I think some of the coolest features are... well, one, how you can export functions to JavaScript. Two, how you can wrap JavaScript functions the way we wrapped that alert function. So you can call back and forth. You can call functions back and forth. You can access the data, and the other thing that I think is probably the coolest thing is right here. Is being able to straight up take the flat memory buffer and read right out of it. Read directly out of the Rust memory buffer. I think this is just so cool. This really makes me rethink what's possible on the front end and in the browser, because you can basically compile native code and write JavaScript extensions. You're basically writing JavaScript extensions in native code. And I guess at the end of the day, you do need at least the little shim of JavaScript. You do need at least the bootstrap. You need the bootstrap that actually loads up the Wasm file. But from there, I guess you could just call like wasm.main and do like everything in there. And I suppose you could modify DOM elements in there too. Alright, I'm gonna clean up this code and then I'm gonna push it up to GitHub. I think this was very cool. I'm gonna have to write up some instructions though. So I already started that readme. Where's the git ignore? Okay, yeah, git ignore should ignore package and target. I want you to also ignore idea and star.yml. Okay, that's the default readme. Let's see. Here we go. Oh wait, the links. Okay. Let's see, does it tell us here how to build and run? Usage, cargo, yeah, build with Wasm pack build. And then I guess I'm gonna add one here that says run in browser to test. And that's gonna be npm start. I guess that'll be cd www. And I'll say I want to put the notes about creating the www folder, history grep www, npm init wasm app, initialize index.html www wrapper, already done, do once only. Yeah, so we already did that, but I want to put notes about how to do it and then start it up. And then Wasm pack publish, if we want to publish to npm. Okay, very cool. So we can just publish our compiled modules. Eduardo says, Rust looks pretty cool, gotta go now. Alright, see you later. Glad you came out and joined and chatted. And yeah, Rust does look pretty cool. Rust is not, this isn't all you can do with Rust. You can actually run and compile regular x86, you know, Linux, Mac, Windows stuff. But you can also target WebAssembly, which is just awesome. Okay. Okay. And you actually need what? You also need Node and npm too, right? Okay. So okay, here we go. So this is our README. I left all of the default README stuff that gives you all the links and all that good stuff, but I also added links to the tutorial and the live stream. And actually, let's leave a link to the source code too, which we haven't created a repo for yet, but we'll do right now. Create a new repo. We're going to call it Rust WebAssembly Game of Life. Now where's the link here? Tutorial. So simple game of life implemented using Rust and WebAssembly, done following that tutorial. Okay. Copy that. In our terminal, we will say git remote add origin. Give it that. Oh. You know what? I'm inside my cookbook right now. I guess I will leave that as a repository of its own. So let's see. Move Wasm Game of Life to my home directory. And then I will repeat my git remote add. Git status. We'll add. Oh, is. What happens? Git reset, git status, git add. Wait, what's going on here? Commit or discard the untracked. I don't know what it's complaining about. Stable working code. So what is this? Commit or discard the untracked or modified contents in submodules. Oh, there's a submodule. Meaning, yeah. There was a git package inside the git package. Okay, so now it should be fine. We're gonna push it up to GitHub. Alright, so now our code should be up. Cool, and we've got our links here to help. Our instructions here. Okay. And it should all... Oh, no, it didn't add the www directory. Okay. So... that www directory is kind of important. How do I undo? Shoot. Git undo submodule add? Jeff Williams also says, if you init by cloning their hello world, don't forget to link and change the is to use the local copy. Git modules. Okay. Interesting. See, I don't even have a modules directory. Let's see, let me try git remove www cp-r www2 just to make a backup. Git remove www, git remove www dash f. Okay, now let me try. Get status. Okay. There we go. I'm just gonna move that one out to my home directory. Okay. Okay, so now if I go check GitHub again, now our www directory is there. And that's really important because that's got like the bulk of the JavaScript logic. Okay, so we've got the WebAssembly and the Rust code living in the live, and we basically just use Wasm bindgen whenever we want to expose something to JavaScript. And we also use Wasm bindgen if we want to wrap a JavaScript function that we want to call. Oh, I shouldn't have left this big gap here, but that's okay. And then we've got our class with our class methods, with some of them exported. And we are even exporting a pointer directly to the memory of our linear memory system. Oh yeah, we could have deleted this too. Since we're not using the text output anymore, that whole section could have been deleted. Why don't we do that real quick? I'm gonna put that way up here. Delete that, clean that up a little bit. Delete up all this extra space. Some of that, some white space there, too much. That whole thing should... I hope I don't break anything when I do that, but that should be fine. Okay, that's a little bit better. Alright, well that was our agenda. We looked at all of these things. And now the code is up on GitHub. So that was a pretty enlightening experience for me. I can see a couple use cases, maybe when doing games in particular. Otherwise, just having a nice compile target. I wonder what languages can compile to WebAssembly. So certainly Rust isn't the only one. I'm pretty sure, yes, C++ can compile to WebAssembly, but like I don't think Go can compile to WebAssembly. Can it? Golang Go, this is the official Go wiki. Go 1.11, which is one of the most recent versions, added an experimental port to WebAssembly. Okay. All you have to do is say, yeah, go arc equals Wasm instead of AMD64. This will build the package and create your .wasm. And it creates a support JavaScript file. And then let's see, how do you call it in Go? Const go equals new go. Go run. Fetch main Wasm. Okay, so this is basically the equivalent of the bootstrap. The bootstrap section. Now npm unlink. cd npm unlink. npm unlink Wasm game of life. Okay. Yeah, just making sure I unlinked all those symlinks. Go exec. Okay. Yeah, so it looks like there is some experimental support with Go. Maybe I'll check that out sometime. But the interesting thing is the fact that we can compile native code binaries for the browser that's cross-browser, and we can basically write native modules for JavaScript. That's really the big takeaway. Awesome. Well, I hope you guys found that interesting. I'm going to go ahead and do my plugs and then wrap up. So you can check out all the code for our projects at github.com/devdungeon. We just pushed up this Rust WebAssembly Game of Life code, and we've got lots of other awesome examples, a bunch of cool stuff. Now, you can also check out the YouTube channel, which you're watching now. Go ahead and subscribe if you want to get the daily live streams. And if you're not already on the Discord server, go to devdungeon.com and click the Join Me on Discord button on the right column. While you're clicking on that button, you should check out the book that's right next to it. My book, Security with Go. You should buy like 20 copies of that. You can find all the blog, text tutorials on the website too. So check out, come hang out on Discord, and subscribe to the channel for more live streams. I will see you all tomorrow. Thanks for coming out.